All right, this is one of the first videos for Math 5500. From the syllabus, you can see that you will be introduced to using R. Says it right there. So the purpose of this video is to introduce you to R. We'll do a lot of pretty crazy things with R before the course is over, but today I'm going to keep it very simple. Just run through how to download R and just do some very basic things in R. So first thing you would need to do is go to a browser, and I prefer Google Chrome. Just type in R. So click it. Now, you know, when I create my videos, I try to create them where there's not a timestamp, but there's not much I can do about this because there seems to be new versions come out quite often. So whatever the new version is, more than likely at the top of the page you have sort of a generic download R link. What this does is it takes you to the Comprehensive R Archive Network. If you'll come down to the United States, which I use, you have quite a few choices. It really doesn't matter. It used to because some crayons were more stable than others, but not recently. I will tell you, as a University of Kentucky fan, it's kind of hard for me to choose Duke or Indiana, but I'm going to get over myself and I'm going to choose Duke. The next thing I would do is I would download R for Mac because I have a Mac machine, and the next thing I would do the latest release. In this case it's 4.02, and I would download that. Just click it and download it. What will happen, and in my case it downloaded right here. Once it's downloaded, I want to click the package. Download time should be very quick. If I'm in my office, I can usually download the latest version of R in 15 to 20 seconds. All right, so let's just run through the process. License, read that if you want. I've read it. Just a bunch of stuff. And just like that, we download R pretty quickly. Well, sort of quickly. Probably going to take you about the same amount of time as well, so at least we're working on it together. At least hopefully we are. All right, guys, close, move to trash. Now, what I want, I use R a lot, so I'm going to go to Applications, and I'm going to drag R down to where it's accessible. And I'm going to click it. And guys, as easy as that is, we now have R open to where we can do some just basic stuff. Now, if I want to get some data in R, which is what we do in statistics, right? One way I could do is just type in the data. So let's for example, I could type in X 1, 2, 3, and I could and type in Y is I don't know, 2, 5, 8. So if I wanted to look at some just basic statistics, the mean of X, I could look the standard deviation for X. I could easily get the mean for Y. I could easily get, and of course the standard deviation for Y I could easily get. Now, if I wanted to look at the relationship between X and Y, for example, if I just wanted to look at the correlation coefficient, I could get that like this, where there's a change of 1 unit in my X and change of 3 units in my Y, so the correlation being 1 makes sense. Now, Probably more interesting and applicable will be a data set, a larger data set. For example, I have a data set here called district, and I will tell you from hours and hours and hours of failure, it's best if we save our data sets in Excel using the .csv extension, because it's easy to get into R. So what I would do here is I would name my data. I'm not very creative, so I'm going to call this data and do read.csv. And then I'm going to district.csv, and guess what? It's going to fail. And the reason it's going to fail is because the default directory where R is going to go look for files is not your desktop. So every time you log in, you just have to change that. So the easiest, or at least the first thing I always do is let's find out where the working directory is currently. So we can do that just with get wd. My working directory is in users SSU Math Masters program. So what I need to do is I need to put desktop on the end of that, so R will go look on the desktop to get the file that I need. And I always put it on the desktop. You don't have to. I always do, just because it's an easy place to find it. So now I have set working directory. So now when I go back up, if I hit the up arrow, I can go back through my commands. And now I can see that I implement this and it's going to work. Now, here's the deal. I can type data, and you'll see they have a large data set, about 480 cases, I think 4 variables. But if I go to, for example, one of the variables is pre. So if I want to see the average pre, it would make sense that I would type pre, right? Well, it's not found, because when we import a data set from our desktop, we have to load the data. We have to attach the data before we can actually analyze the data. So now when I go to mean pre, you can see that I get 72.15 as the mean pre. I do the same thing. You know, there was there post. I'll tell you something I like to do. I like to just do head data, so it gives me the first 6 rows. And I'll tell you what, let's pump the brakes a little. Well, I'll pump the brakes just a little bit. This is a classic format of a data table that we'll use, because when we read left to right, we have the cases, and when we read vertically, we have, of course, our variables. Now, people who don't have a strong background, or at least a limited background in statistics, when they see a table like this, they naturally read left to right. Why? That's where the juicy gossip is. We can see now that this student, the 3rd student in our data set, has a 55 on their pre-test. They decreased drastically on their post-test. Of course, I don't know what the scale was here, but at least the score went down. The pre may have been on a 100-point scale, and the post may have been on a, who knows, a 40-point scale. I don't know. But anyway, I know they're from District A, and I know that they are in a STEM track. People with a strong background in statistics could care less about reading left or right. We care about vertically, right? First thing I look at is I see pre as quantitative. Well, I start thinking, well, what's the box plot look like? What's the histogram look like? What's the distribution shape? What's the mean? What's the median? What's the standard deviation? So what's the measures of central tendency? What are the measures of variability? Same thing for post, because it's quantitative. When I get to district and track, I can see that they're not quantitative. I can see that these are categorical. So I start thinking, well, what percentage of, so if I go up, I could see that the school districts look like they run from A to H. So what percentage of students are in A? What percentage of students are in B, and so on. And same thing with track. So I can take a look. If I want to look at a histogram of a quantitative variable, it's really easy to do. And we can see that we have, you know, the classic kind of bell-shaped and symmetric distribution. Do not, please do not, unless you want to get on my last nerve, call that a normal distribution. Normal distribution is a probability distribution. It's a theoretical model. We have a sample here. So sample histograms don't lead to normal distributions. They lead to approximately bell-shaped and symmetric distributions. We could also look at a box plot of PRE. And again, we have no outliers, and we have a relatively symmetric distribution. Switching gears to district, what I would want to do there is probably just look at a table. It's not going to give me a table, it's just going to give me a frequency across the districts. So we can see that we have exactly a symmetric proportion of students in each of the districts. Same thing for table across track. We can see that we have 160 students are in QR, 160 in stats, 160 in STEM. Now I think the interesting part actually comes to when we look at the combination of the variables, or at least the relationship between the variables. So, you know, if I were interested in this, I don't even really know what this data set represents, but if I was really interested in it, I may want to, you know, look at the means of PRE across district. And it turns out that that's really, really easy to do using the t-apply function. So I can do PRE across district. And I want the function to be mean. All right, oops, first mistake I've ever made, guys. All right, so as we glance across the districts, we can see that the pre-score average was quite a bit higher for D, especially than A and H. I can go up, and maybe I just want to change district to track. And from this information, it looks like the pre-score for the QR students was quite a bit higher than for stats, and especially for STEM. If I want to get fancy with some box plots, I can do a box plot of, I don't know, let's just do post across district. I can see that there's some outliers. These isolated dots right here are outliers. So for District F, there are no outliers. District E, there's an outlier. So it looks like District F, for the most part, performed the highest. So these dark bars in the middle, as you probably know, stand for the median. So this is the lowest value. This is Q1. This is the median, Q3. The highest value that's not yet an outlier, the highest value would be 60, which is the kid from school district A. Within that district, this observation was ruled to be an outlier. If you remember when we did, well, I don't even know if we did post as a whole. Yeah, when we did post as a whole, we didn't get outliers. So that outlier would be in comparison to the other scores within the school district. So guys, just some cool things that we can do. We're going to get pretty messy with this. If you want to find sample size, you would think you would do sample size, but you don't. You would do length. So if you want to do length, for example, PRE, we can see that we have 480 scores in PRE. Something that we can actually do, and this will be the last thing I'll show you because I don't want this to go too long. We can just go summary data, And it really doesn't give you anything very meaningful for the categorical variables, but it does give you some decent stuff for the quantitative. It gives you the 5-number summary, the min, Q1, median, Q3, and max. And then it throws in, for some reason, it throws in the mean, but it doesn't throw in the standard deviation. So if you want the standard deviation, you gotta earn it. You gotta type it in. And again, it's easy to do. Standard deviation would be 8.02. Well, gang, that's all I got. Just keeping it simple. I want you to get R downloaded to your machine. You'll use it on your assignments. You'll use it. Every instructional video will use R. You'll use it on your exams. So use it a lot. All right. Take care.